Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so today we meet again with our next lecture, that is lecture 11, Dynamics Rectilinear Part 2. Okay, what have you learned previously? Previously, you have learned about the term in rectilinear. So you have learned about the positions, x, distance and displacement, speed, velocity and acceleration. So what is the most important is you need to understand the relationship of the integration and derivation of this parameter. For example, for position or displacement. So from the equation of displacement, you can get the velocity by do the derivative of position ds dt, and to get the acceleration, you derive dv dt. So and to get back the velocity from acceleration, need to integrate it, and to get back the position from the velocity, we need to integrate also. So this is the mathematical equation. So we revise again for the differentiation. For example, if the equation is x, after differentiation you will get 1. And for ax, after differentiate, you will get a, the value of x here. And differentiate x power of n, you bring n to the forward, and then n minus the power of n minus 1. And for integration, for to integrate 1, you will get x plus c. C is the constant or initial value of it. And integrate a, we will get ax plus c. And integrate x, and we will get x n plus 1. And then the n plus 1 bring at the bottom plus c. In today's lesson, we will focus more on the graph. Graph in rectilinear, graph of integration and derivation, acceleration in horizontal and vertical, and step to answer the rectilinear motion question. Okay, there are five types of graph in rectilinear. That is, the first one is position versus time. So the time is the x-axis, and then s is the position is the y-axis. And then if you have, for example, we have this kind of graph, and then the gradient is the velocity. So this is ds over dt equal to v. So this gradient is the velocity. And then the second graph you can use in the rectilinear is v versus t. So and then the gradient is the acceleration. So dv dt equal a. And then the area under the graph is the displacement s. But for st, there are the area under the graph is no meaning of that area. Okay, for the third one is this one is a and t. and you will have like this. So this one, the gradient, no meaning, there are no meaning of the gradient, but the area under the graph is the V. And then there are another graph. You also can have graph V versus S and A versus S. Okay, this is the relationship of time domain graph. From previous slide, there are three graph of time domain, that is ST, VT, and AT. So this one is, for example, y equals 0. Okay, the graph is like this. And this one, for example, you have y equals 5. And then toward bottom, they integrate it. So it's become y equal 5t. And then 5t is like this. And then y equal 5t squared. It's become quadratic like this. And this one for the negative, y equal negative 5, and then y equal negative 5t, and y equal negative 5x and y t squared. So this is the relationship between the derivative and integration graph. Okay, for the acceleration occur due to the change in the magnitude of the velocity, direction of the velocity, or both of it. So if the velocity change on the magnitude, it also can have the acceleration of, and if only change the direction, also the acceleration occur. An acceleration of object projected vertically perform rectilinear motion with uniform acceleration with magnitude same with gravity. G equal 9.6 and 9.81 ms squared. So for example, you at the 10th level of flat house, and then you throw away ball. So the acceleration of the ball is equal 10 ms squared. Okay, previously we only concerned with the velocity that is constant. For example, v equal ds dt. So this v is the constant v. Okay, how about if the velocity is not constant? Not constant, you will have u for initial velocity and v for final velocity. So there are three equations that you can use to solve the equation with the velocity not constant. For the first one is v equal u plus at. Okay, this one you can remember this equation, or you remember the step to derive it. This one is from E equal v minus u over t. This is the equation for acceleration, where the final velocity minus the initial velocity over time. So you rearrange it, you will get v equal u plus at. Okay, this is the first equation, and then the second equation is s minus s naught equal ut plus half at squared. Okay, this one, how to get this equation is okay, from here. Okay, v from the previous equation, v equal to u plus at, and then we also same as ds over dt. So ds over dt equal u plus at, and you move the dt toward u plus at, we will get ds equal u plus at dt. Okay, and then you integrate both of these, you will get s from 0 to t s e 0 to s, 0 to s equal ut plus at squared over 2. Okay, this one from 0 to t, 0 to t. So you will have s minus s naught equal to ut plus 1 1/2 at squared. So you will get this equation. Okay, for the third one is based on the first equation also. V equal u plus at. So square both of the side. V squared equal u plus at squared. So become u squared plus 2 ut plus a squared t squared. Okay, and then you can, v squared equal to u squared plus, you take out the 2a, and then you will get ut plus a t squared over 2. Okay, and this one ut plus a t squared over 2 is equal to s minus s naught. So it becomes u squared plus 2a s minus s naught. Okay, so these three equations you can use in the to solve the question. Okay, step to answer the rectilinear question. There are two methods that you can solve the rectilinear question. The first one is by formula, and the second one by graph. Okay, for the first one, list down the parameter given by formula. So you need to list down the parameter given, substitute into suitable formula. This one is the equation from for the rectilinear motion, and this is parameter. You can choose the best equation to solve the question. And the second one is write equation for each segment and take note on the x-axis value. Okay, this one, because okay, for example, if uh, there are 5 type of graph I explained before. There are t, x, or v, or a, and another is s, either v or a. Okay, for example, here you need to list down from t from 0 to something to n. For example, the a equal what? This one, instead of t before, this one is s. S from 0 to n, the v equals something. We need to take note this parameter. This is important. Okay, let's try solve the first example. Okay, this one, a car starting from rest move along a straight track with an acceleration as shown. So this is acceleration A versus t, and determine the times t for the car to reach speed of 50 meter per square, and construct the VT graph. Okay, there are two questions. The first one is to get the time for speed, and the second one is the graph. Okay, how to solve it? Okay, for this one, like I explained before, because this is the solved by graph, you need to write the equation based on the x value. So for this one, the x value is t. The t from 0 to 10, the equation is 4 over 5t. This one, how you get this is this one is y over x. Okay, this one is y over x. The y is 8 minus 0 over 10 minus 0, become 8 over 10, or you can simplify 4 minus 5. Okay, so you get the 4 over 5t, and t more than 10, the constant 8. Okay, the question is determine the time t for the car to reach a speed at 50 milliseconds. Okay, this one, the graph is A versus t, but the question want the speed. The speed is v. How to get the from A to t, A to v? To get A to v, you need to integrate. Okay, integrate the A. So after integration, 4 over 5t, you will get 4t squared over 10 from 0t. So this is the equation at this, and at 10. Okay, this one, how to solve it, because we didn't know the 50 millisecond and 50 meter per second is at which time. So we need to try first for the first equation for t squared over 10. Sorry, this one actually for sorry, this one is 5. Okay, 4t squared over 5, and you will get the speed is 40 millisecond. 40 millisecond. So this one is less than what we expect. That's we want 50 millisecond, and we need to integrate the other part, that is the t over 10 second. So after integration, we will get 8t. From this integration, 8t minus 10 put into this t, you will get 8t minus t. Okay, this is actually plus c. C is the initial value. Okay, the initial value is the t when the t is equal 10. What is the value? So we already calculate it. The value is 40 meter per second. So you just put plus c into 40. So you will get the equation for v at t over 10 is 8t minus 40. Okay, this is the equation, and put this equation. This means we want v at 50 millisecond. Okay, 50 meter per second. 50 equal 80 minus 40, so you will get the time is 11.25 seconds. So this is the time for the car to reach the speed of 50 meter per second. Okay, there are another question. In this question, there is construct the VT graph that describe the motion until time t. Okay, this one is from the integration. You get the this one is 4 over 5 t squared. I think this is right typing error again. This is 4 over 5 t squared, and then after 11.25 it's become 8t. Okay, and for the second example, if a particle has an initial velocity of 12 feet per second to the right at s0 equal to 0, determine its position when t equals 10 seconds if a equal to feet over s squared to the left. Okay, this one. Okay, for this question, this is suitable to use the equation method. So list down the given parameter. It's given the u is 12 feet per second, and then s0 is 0, and then a equal to negative 2 feet per s squared. Okay, negative because it's toward left. And then list down what's the question one. What is the position when t equal 10 seconds? Okay, this you can use this equation, and you can use this equation, put all the parameter given, and so you will get the position is 20 feet. 20 feet. Okay, that's all for today lecture. Any question you can ask me. Okay, Assalamualaikum warahmatullahi wabarakatuh.